What's up, guys? It's your boy. We're doing some physics here, testing our understanding. We got Newton's first law. Alright, so Newton's first law says that if all forces of an object balance, or all forces on an object cancel, or the net force on an object is zero, then the object moves constant speed and constant direction, aka constant velocity. Alright, so testing our understanding. We've got a box as large as a person that rests on a floor. The student pushes to the right. Okay, student pushes to the right for the first 5 seconds, then the student exerts a force on the box stronger than the frictional force on the box. Then for 5 seconds, the student's force is exactly as strong. Alright, so we're drawing free body diagrams for these first. So we know that for the first 5 seconds, the student exerts a force on the box stronger than the frictional force, which means that we will have some movement going on. First, let's take care of the two forces that cancel each other out. 1 box, 2 box, 3 box, 4 boxes. They cancel each other out, so they need to be exactly the same length. Okay. If this were a question on a test of some sort, then it's important that you make those exactly the same length. And then, so the weight is going down and the normal force is going to the right. So that's our vertical direction. Let's look at our horizontal direction. We've got pushing more than friction. And we know this one is F, and this one he's pushing it with his hand, so we're going to call it FA. Okay, so there we go. Or we can call it F sub S for student, but A for us tells us that his hand is actually causing the motion. Then for 5 seconds, the student's force is exactly as strong as friction on the block. Alright, so the first thing we got to take care of are the two vertical forces that cancel each other out. And again, every time on a free body diagram, we are labeling every vector. We're keeping every vector a length that is meaningful. Alright, so now we're going the same length with our applied force as friction. Ooh, so that means we're canceled out in the vertical and we're canceled out horizontal. That must mean, according to Newton's first law, all objects balance or cancel, then the object is moving with a constant speed. So that's what's happening right here, constant velocity. Then during the last 5 seconds, that we have the student's force is less than the force acting on the box. Okay, so that means friction is winning. Maybe the student's getting tired or something like that. Frictional force, I want to keep my frictional force as long as I have had it in the other parts. So we have frictional force and we have A. Now let's not forget about FW and normal force. There we go. Draw a possible motion diagram showing that the box motioned for the first 15 seconds. And then draw a dot for each second. Alright, so we're going to go to here. We're going to go to blue. Each second that goes by. So first second, what's happening in the first 5 seconds? It looks like we're speeding up. 2, 3, 4, 5, and then we are moving with a constant velocity. I'm going to do my best to make these equal. And then what's happening here? Well, remember, if we have velocity in this direction and our net acceleration, or our net force, is in the opposite direction, then that means we're slowing down. So we are now accelerating, but slowing down. Sometimes you may hear that as called decelerating. So here's our motion diagram. There's the dots. You'd want to label this as 1 second, 2 seconds, 3 seconds, and so on. I won't go through that. And then remember, the last thing we do with a motion diagram is we draw our velocity vector. And here we can see our velocity vector is growing until we're here where it's constantly the same length, because we're moving at a constant with a constant velocity. And then we start getting shorter. Okay, got it? All right, so that takes care of Newton's first law, the first test your understanding. If you have questions, ask each other, ask me. Other than that, don't forget, like, comment, subscribe, hit that bell notification so you know when the next physics is dropping. All right, see you next time.